animals.
Yes.
You see, millions of years ago, due to some disaster or due to some flood, so many plants they died, so many animals they died. Okay, either
Yes.
either there was some uh, our planet that is first got hit by meteoroid. Okay, or either there was volcanic eruption or there was floods due to which the plants and animals they died at a larger scale. Okay, so in the ocean, all the fishes and aquatic plants they died, and over the period of million years, they got deposited under the layers. Right. So
Yes.
after millions of years, the dead plants, and animals inside the ocean, they got converted into petrol. Right. And coal were not formed from the dead and decaying fishes and animals. Coal is actually formed from the dead and decaying plants. Right. So when there was a flood or when there was a volcanic eruption or some other natural disaster, large scale of plants, large scale of forests, they died and gradually they were buried inside the soil. Okay, and over
Sir.
the years, layers of soil, dirt deposited over the buried plants. Okay, over the buried plant, over the period of million years, more and more layer of sand, rocks, and dust deposited over them. So due to this, more and more pressure accumulated over the buried plants. So due to more and more pressure and heat, they gradually got converted into coal. So if someone
Sir,
asks you, yeah, am
can
I
you
audible
explain
properly?
how is fossil fuel formed?
Hello,
Sir, can you explain me how is fossil fuel formed?
can you explain why?
Can you explain how is fossil fuel formed?
How fossil fuels are formed? I'm actually not able to hear your question, sir. Can you speak more
Sir,
clearly?
how is fossil fuel formed?
Yeah, how is fossil fuels formed? Okay, how is fossil fuels formed? Okay. Before we even talk about the formation, that if we get to understand it, the fossil fuels are what? They are the dead remains of plants and animals, right? Fossil fuels are dead remains of plants and animals. So millions of years ago, when there was a flood, when there was volcanic eruption or some other natural disaster, millions of plants and animals they either got deposited inside the soil and they got either crushed between two rocks. There was a lizard, let's say. There was a lizard who got crushed between the two rocks, right? Or there were so many fishes who died and got deposited inside the under the layers of the ocean. So gradually, after so many periods, so many years, after millions of years, they were basically preserved and they got converted into fossil fuels, right? They get converted into fossil. So, so in museums, you will find that in museums you will get to see dead remains of dinosaurs. You will find bones of dinosaurs. You will find so many insects which are perfectly preserved. You will find that there are so many snails which are perfectly preserved between two stones. Right. So due to accumulation of pressure and temperature over a large period of time, they got submerged under the seabed or inside the soil or between two rocks. Okay. And they were not exposed to external elements. Like when a lizard was crushed between two rocks, okay, and these two rocks joined over a period of time, it became they joint became between these two rocks. After so many period of rock, after so many period, these two rocks became one single rock. And this lizard got trapped inside this rock. So you see, this lizard is not getting exposed to air, temperature, it is heat. So this Lizard is not being exposed to air or heat. That's why its body will not decompose. So it got preserved. Right, guys? So that's how fossils were formed.
Yes.
Okay. Okay. So currently you say that this chapter is going on in your class. Okay. But before we continue with the chapter, there are few basic things. Let's cover them. Okay. So in your previous class, you have already studied about different things like nutrition in animals. You must have studied about heat, right? You must have studied about acids, bases, and water salts. Have you studied these topics?
Yes, sir.
Okay, very good. So let's take a small test here. Okay. I've got few questions for you, and based on your performance, we will move ahead. So see question number one. Read the question number one. What does it say? The carbon dioxide gas enters the leaf of the plant through dash present on the surface. Right. The plant, they do photosynthesis through their leaves, and on their leaves, what are present? Xylem, stomata, leaf veins, sepals, all four of them are present there. But with which component they do photosynthesis? There I have. Hello.
I can't hear you.
Am I audible?
Yes, but your voice like lagging.
Am I audible now?
Yes, not.
Okay. So I was saying, let's do this test. Okay, and based on your performance, we will move further. Okay, see the question number one and answer the question. Understand what is the answer of the first question?
Tomato.
It's tomato. Very good. See the second question. Which of these is not parasite? Hookworm, leeches, summerbill, a fisher plant. There are four different organisms here, right? Some are plants, some are animals. Okay, and you have to mention which one of these is not a parasite. Parasites are basically those organisms that get their nutrition from other organisms. They themselves do not produce their own food, but depend on other organisms. Basically, they live inside the body of other organisms, right? Right, Cam? Which of these is not a parasite? If you see leeches, they basically stick to the skin of the human body or animal and they suck their blood. So leeches are also parasites. Okay. What about amberbill? Ever heard about them? They are also parasites. Hookworms are also parasites, while pitcher plant is not parasitic in nature. Okay. So our answer is pitcher plant. Next question. Silkworms secrete fiber made of. You see, silkworms whose fiber are used to make silk. Okay. So their fiber basically is made up of what? Cellulose, protein, nylon, or fat. Rehan, can you hear me?
Yes.
Yeah. Let's participate in this test. Okay, you have to actually answer the question. Okay. What is the answer of this question? You see, silkworms,
Protein.
not protein. They actually contain cellulose. Okay. See the next question. Which of the following is false? You must have studied about acids, bases, and salts in your previous class. Okay. So acids are what? Which substances? Basically, they are sour in taste. Bases, they are bitter and soapy to touch. They are bitter in taste and they are soapy to touch. Okay, they are slippery to touch. Okay, salts, they are neutral. Okay, neither do exhibit property of acid, neither they do exhibit property of bases. They are neutral, in between acid and base. Okay, so to measure whether a given substance is acidic, basic, or neutral in nature, we have developed a pH scale. Okay, it basically reads from 1 to 14. Okay, 1 to 14. Okay, so we have divided it into two equal halves. So all substances which have got pH value of which have got pH value lying between 1 to 17, they are called acidic substances, right? And those substances whose pH value lies between 7 to 14, they are called basic substances. Okay. What about those substances whose pH value is going to be 7? Will they be acidic or basic or neutral? Yes, they are. Hello. Hello. Yeah. I said, as I say that the substances whose pH value is between 1 to 7, they are acidic in nature. And those substances whose pH value is between 7 to 14, they are basic in nature. What about those substances whose pH value will be 7? Will they be acidic, basic, or neutral? Aryan, if you don't know an answer, it's okay to say no. Okay, I'm here to help you. Okay, so those substances whose value is neither acidic or basic, they will have pH value of 7. Okay, that they're lying between acidic and basic. Okay, so our question says that which of the following is false? Like there are three statements given here. Read the statement for me. Read the options. Just read the statements aloud.
Sir, I don't know.
Okay, so which option is false?
Sir, acidic pH value is less than.
Can you please speak more clearly?
Sir, acid have pH values less than 7.
No, but that is wrong. You see, as I already said, that acid's pH value lies between 1 to 7. So it could be less than 7. As I already told you, that neutral substances will have a pH value of 7, which we just saw here. You see, neutral substances will have a pH value of 7, like water. Water is neutral in nature. It is neither acidic nor basic. So its pH value will be 7. Okay. So if you see the question, option number third, that is neutral have pH value of 40. That is actually false. Okay. You have to actually answer which option is false. The third option is false. Okay. Now one more question. That what is the correct way of making a solution of acid in water? Like you must have heard about experiment that how we make solution of acid in water. Like do we add acid to water or do we add water to acid?
Sir, acid to water.
We add acid to water.
Yes.
That is very
Acid.
correct. We add acid to water. Why? Because If we add water to it, that might lead to explosion. Right? That might lead to explosion, and we might get injured. Okay, because acid is having so much of energy that if you add water directly to acid, there will be an abundant amount of release of energy in the form of fire, okay, or in the form of explosion. That's how we don't add water directly to acid. Okay, okay. So let's discuss few basic things from your previous class. Okay, like you must have studied about mode of nutrition in plants, right? You know, plants are the only autotrophic organisms present on the earth. Okay, so they have evolved in such a way that they can synthesize their own food. They can make their own food with the help of raw materials from their surroundings, right? So plants basically they take a carbon dioxide, water, and in the presence of sunlight, they make their own food, which from by a process that is called photosynthesis. Right? You must have studied about this earlier. Okay. If we talk about mode of nutrition basically means like if we talk about plants, they can prepare their own food. That's why we call them the autotrophic organisms. Auto basically means auto basically means themselves. Auto means self, and trophic means nutrition. Basically, we all humans or whether animals or plants, they all need nutrition. So those organisms which can provide nutrition to themselves, to those organisms which can provide nutrition to themselves, they are called autotrophs. That is, they can provide nutrition to themselves. So plants are called autotrophs. While we humans and other animals like lion or fungi and most of the bacteria, okay, they basically depend upon plants and they consume other animals for their survival. We basically depend on plants and other organisms for our survival. So we are called heterotrophs. Why? Because we cannot provide nutrition to ourselves. We actually depend on the food prepared by the plant and the meat and egg and milk of animals. Right, Aman? Right, Rehan? Okay. So we are called heterotrophs. Heterotroph. So hetero, what does it mean? Hetero means others. Hetero means others. Troph means nutrition. So others nutrition, depending on others what. So heterotrophic organisms are those organisms which will depend on other organisms for their food. Right. Also, you tell me in an ecosystem, we basically organisms are divided into producers. Okay. Then we have consumer. Right. Then we have got consumer. So producer is basically what? Producers are plants, right? And consumers are what? Consumers are basically herbivores. Herbivorous animals. What are herbivorous animals? Yeah, Ahmed, what are herbivores?
Sir,
What are herbivores?
sir, animals those eat herbs, plants.
Animals that eat plants, right? So herbivores are consumers. What about carnivores? Are they not consumers? Carnivores
No,
consume herbivores.
no, sir.
Why not? Carnivores they consume herbivores. They eat herbivorous animals.
Yes, sir.
Right?
They eat flesh.
Exactly. And then comes omnivorous as well. Omnivorous will consume herbivorous as
Both,
well as
sir.
plants.
Yes.
Right.
Yes, sir.
So you see, all these three consumers, they are heterotrophic in nature. Okay. They cannot produce their own food. They depend on plants directly or indirectly for their survival. Okay. Now there's one more fundamental element here. It's actually the sun. Because in the process of photosynthesis, sun plays a very fundamental role. Because if there is no sun, if the sun vanishes, plants will die. All plants will die, means all herbivores will die. All herbivores will die, it means all carnivores will die. And will the omnivores survive in that case? If the plants and herbivores die, their survival will also be in danger. Right? Right, Rehan?
Yes.
Okay, so you see, the survival of all of the consumers are interdependent, either on each other or directly dependent on the plant. Okay, and sun plays a major role. Okay, because in the process of photosynthesis, we require sunlight. Okay, we talk about the raw materials required in the process of photosynthesis. What are they? Oxygen, right?
Yes, sir.
It's actually carbon dioxide, not oxygen. It is released. Plants require carbon dioxide, right? Plants require water. Okay, and the whole process takes place in the presence of sunlight. Okay, and plants make their food in the form of glucose. Okay, and they release oxygen into the atmosphere, which we breathe. Okay, so this whole process is called what? This whole process is called photosynthesis. Right, Emma? Right. Okay. Now, there in your previous class, in class 7, you must have studied about fiber chapter, fiber to fabric. Right? How the fiber which we obtain from plant is converted into fabric, the clothes which we wear. Okay. So there are different types of fabrics which we wear. It could either be synthetic or it could be natural. Okay. So let's two natural sources of fabric. What are the two natural sources of fabric which we wear? What about cotton? Cotton is a natural fabric, right? Wool is also natural fabric, right? What about silk? Silk is also a natural fabric. Why? Because they are coming from plants and animals. Okay. Cotton, they come from cotton plants. Wool comes from sheep, yak, goat. Wool comes from sheep, yak, and goat, and from camel as well, as you can see here. These are the different animals which are reared for wool. Alpaca, goat, camel, yak. They give us wool, right? So do they give us wool in the pure form? No. We actually have to process them, right? We have to clean them. It goes to the processing unit. There they are separated, and the dirt and the worms from the wool is cleaned out, and then they are dyed into different colors, and then it is woven into thread. Okay, and then it is ready to be sold into the market. Okay. What about silk? As you already know, silk comes from silk. Who will tell me silkworms are found on which plant? Yeah, Ahmed, silkworms are present on which plant? Silkworm, as already know, they consume mulberry leaves, right? Am I audible properly? Yes, Ahmed. Silkworm, they consume mulberry leaves. They consume mulberry leaves. Okay. Okay, back to where we were discussing. So our discussion was about the process of obtaining wool from the hair fiber of the animal. Okay, as you can see in this figure, this man is actually cutting the wool from the body of this sheep. Okay, so that process is called shearing. This is basically the removal of wool from the body of the sheep. In the
Yes,
next
sir.
process, you will see that the wool is sent to a mill. Right? They stock them like this into bundles and they send them to the mill.
Yes,
There
sir.
they clean it with water. Okay, basically they remove all the dirt particles present in the fleece. Okay, and after that you will see what happens. Cording machine combs the loose wool fiber into a sheet. So basically they spread out the wool into sheet-like structure. They spread it out. Okay,
Oh,
and while they're spreading out, if there's some unwanted substances left there, they remove them as well. Okay, now you see the sheet is twisted into a rope called silk. So here you can see that they have spread out like this, and from one side they are being twisted into a rope. Okay, so that rope is being called a silver. It's called sliver actually, SLIVER. And after that, you see the yarn is going to form balls of yarn. The sliver is further stretched and twisted into thin yarn. Thin yarn basically means thread. Okay, so that's the process of the conversion of wool into usable form in brief. Let's discuss each of the processes. First process is the shearing process. Okay, it is the
yes, sir.
process of removing the fleece of the sheep along with a thin layer of its skin. Okay, shearing is conducted generally in hot weather so that the sheep do not feel cold and can survive in heat. Now, let's say if there's a farmer who does the process of shearing in cold weather, is that a good thing for the ships?
No, sir, that's not a good thing.
Right, the ships will die due to cold. So
Yes, sir.
generally, they remove the fleece of the sheep during summer so that it's a relief for the sheep as well. They do not feel warm. Okay, so
Yes,
the
sir.
shearing process, if someone asks that does it hurt the animal? No. If we cut our hair, does it hurt us? No, because hair does not contain living cells. So the shearing process does not harm the animal. Okay.
Yes, sir.
The next process is scoring. What happens in this? It is the process of removing dirt, grease, and dust from the hair removed from the ship. It is generally done with the help of machine. The scoring, as you can see in this figure, this process is actually scoring. Okay, it can either be done manually. Normally, they use since they are doing the production on a larger scale, they take help of machine. So since they are not dealing with 1 or 2 kg of fleece, okay, they are dealing with hundreds and hundreds of kgs of fleece. So they take help of machines to remove the dirt. Okay, the scouring is nothing but it is actually the process of removing dirt, grease, or dust from the hair which is being removed from the sheep. After scoring, what happens? We basically sort the fleece. It is the process of separating the hair of the sheep according to their texture. So all the sheep, they do not have the same color of their hair. Some might be white, some might be blue, some might be yellowish, some might be reddish, some might be brownish in color. Right. So based on their color, they are separated. That's called sorting.
Yes, sir.
In the step 4, we remove the birds. Okay. In this step, what happens? The burrs or small fibers present on the hair are picked out. Okay. Then the hair is cleaned and dried out. The product so obtained is the wood that can now be converted into fibers. Okay. So at this stage, we can say that our fleece, our fiber is clean and okay. And at this stage, small tiny fibers, which are of no use for us, which are present on the hair, they are basically picked out manually. Okay. This process cannot be done by the help of machine. It has to be hand picked. Okay. So Ask,
Yes.
someone asked you what are birds? Birds are basically small fibers.
Oh.
Now, after the cleaning process and separating process has been done, now we can color the wool fibers as per our choice. Okay, in this state, the fibers are dyed in different colors. Okay. Now, once we have dyed fibers into different colors, we can roll the wool. This is actually the last step. Okay, it is actually straightened out, as you can see in this figure.
Yes,
This
sir.
actually is straightened out, and the roll, they are rolled by the help of this roller.
Yes.
Right, Rehan? We take help of the roller and roll this sheet into form of a rope. And that rope is called what? That rope is called sliver. SLIVER. Okay. Okay. I hope the process of this process is clear. Okay. Let's discuss few things about one more chapter which you must have studied in the previous class: acids, bases, and salts. Okay. So who will tell me what are acids? Rehan, you tell me what are acids.
Yes, sir.
Rehan, am I audible to you? Rehan, give me two examples of acids which we consume on a daily basis. Not on a daily
Two
basis, but
examples of,
which we usually consume. Examples of acids.
sir, I can't hear correctly.
I'm asking, give me two examples of acids.
Sir, can you type in the text in the chat?
Ahmed, am I audible to you? Or am I not audible to you as well? Ahmed, can you hear me? Hello? Yeah. Can you see the question?
Sir, no, I can't see. Sir, in
So
the
what is,
chat.
is there? Just and what are the two examples of acids which we consume? Acids can be found in natural fruits as well, and they could be made in chemical lab. They can be made in labs as well, right? So if I tell you the properties of the acid, then will you be able to answer? Like the first property of the acid is that they are sour in taste. They are sour in taste. They have got a sour taste. Okay. So one example of acid could be lemon juice, right, Ahmed?
Yes, sir. Yes, sir.
Okay. Lemon juice is sour in taste. That's why it is
Yes.
acidic in nature. What about the dilute acetyl acid, hydrochloric acid?
Hydrochloric acid. Such. Is it a base?
No, it is actually an acid. You see,
Oh.
earlier people used acid to clean washrooms and basically to remove some dirt from things. They used acid, or usually in washrooms, in bathrooms, they use hydrochloric acid. But now we have got more skin-friendly chemicals because acid is difficult to deal with. It could harm us injurious. But earlier people
Yes.
used to have acids in the bathrooms for cleaning purpose. So
Yes.
hydrochloric acid is also used. Lemon juice is also a good example. Okay. If we talk about acid, the first property of acid is that they are sour in taste. Okay. So many food items such as lemons, curd, vinegar, and orange taste sour because of the presence of acid in them. Okay.
Yes,
So
sir.
acid is also divided into two divisions. One type of acid will be natural, which will be naturally found in fruits. Okay.
Yes. Yes, sir.
It could be found in curd as well. Okay. And the another type of acid is made in labs. Okay. Like the one example which I just took, that is the hydrochloric acid. It is not found naturally, it is actually made into labs. Okay.
Yes, sir.
Okay. So natural acids are the acids that occur in nature. For example, acids found in fruits. Okay, they are the natural acids. Okay. And what about the chemical acids? Or we can actually say them as synthetic acid as well. Right. One example
Yes.
of synthetic acid is HCl, that is hydrochloric. Okay, remember the example.
Yes, sir.
If we talk about bases, you see the soaps which we use at our home. Are they basic or are they acidic in nature?
Yes, sir.
The soaps which we use in our home for cleaning purpose, are they basic or are they acidic in nature?
Sir, they are basic.
They are basic in nature because if they were acidic in nature, they would erupt, they would harm our skin, right?
Yes, sir. They will itch our skin.
We will observe itchiness in the skin. So bases
Yes.
are the chemical substance that has a bitter taste and a soapy texture. Okay, the taste is bitter. The taste
Yes,
is
sir.
bitter. Okay, and the texture is soapy. If you touch them, it will be slippery and soapy in nature.
Yes, yes,
Okay,
yes.
and bases are found in different substances like the bleach, ammonia, washing powder, soap. You can add one more, baking soda. So baking soda, which we use at our home, is also a base.
Base. Yes.
Okay. Now, in your previous class, you might have actually heard of pH scale as well. Okay. So we cannot taste every acid because the acids which are synthetic in nature, they are very harmful and they are very strong acids. We do consume orange juice. There's no problem in it because they are weak acids. But can we
Yes.
consume harmful acids which are very strong? Basically, the question is that how do we say whether a substance is acidic or basic in nature? We cannot keep on tasting them to see whether they are acid or basic in nature, right? Because they might actually they might be harmful for us as well. So we develop pH scale.
Yes,
We
sir.
develop pH scale to determine acidity and basicity of substances. A pH scale actually ranges from 1 to 14. Okay, and so those substances which will lie between 1 to 7, those substances which will have a pH value lying between 1 to 7, that will be called acidic in nature. Okay. And those substances whose pH will be value will be more than 7 and will lie between 7 to 14, that will be called basic in nature.
Yes, sir.
Okay. What about those substances which have got a pH value of 7? They will actually be neutral in nature. Like if you consider
Yes.
water, water is naturally not basic. It has got a neutral property. Okay. So water is neutral in nature and has got a pH of around 7. Okay.
Yes.
Okay. Okay. Name one acid which is actually found in our body,
In our body.
in our stomach. You see this acid, hydrochloric acid.
Hydrochloric acid.
Hydrochloric acid is actually found in our stomach. The food which
Yes.
we eat, eat hydrochloric acid, basically they kill all the germs found in those food. Okay.
Yes, sir.
Okay. So I'm curious why you haven't posed a question that acids are harmful. Acids can harm our acids can our why the acids are not harming our stomach? Because to counter the effect of hydrochloric acid, we have got hormones in our stomach also, which does not allow the acid to harm the stomach. Okay.
Okay.
Like
Yes, sir.
normally, if you pour the hydrochloric acid on the skin, it will harm this thing. It will corrode this. But why that hydrochloric acid it's not harming it? Because to counter the effects of hydrochloric acid, to neutralize its effect, we have got hormones in our stomach as well. That does not let the acid harm us.
Yes,
Okay,
sir.
I hope it's clear. Yes, Rehan, am I still not audible? Rehan, can you hear me? Rehan, I think there's some problem with your mic connection because Ahmed can hear me properly.
Sir,
Okay,
I can, but it's not clear.
I guess there's some network issue. From my side, I guess it's clear. Okay. See the neutral substance, which you're just talking. They rather exhibit acidic, not basic property. Okay, they love to remain neutral. Okay. Rather
Yes,
acidic,
yes, sir.
not basic. Okay. So we cannot taste every object and find its nature, as I just mentioned earlier. Okay, because there are some very harmful and strong acids. If we taste them, our tongue will be burned. Therefore, we use indicators. So I'm guessing you must have studied about indicator, that is the litmus paper. You must
Yes,
have studied about this in this class.
litmus paper. Yes, sir.
Right. Litmus paper is actually a national indicator. We find a national substance in our nature or lichens. Okay. So from
Yes, sir.
lichens we convert the lichens into paper form. That is, we convert them into blue and red paper, like in the figure see here. If you take a blue litmus paper, okay, and you dip it into the acid, that blue litmus paper will get converted into red. See how its color has changed,
Yes,
right?
sir. Yes,
And
sir.
if you take a red litmus paper and you dip that red litmus paper into a basic solution that is basic in nature, okay, that will get converted into blue, right?
Yes.
You can say that acid converts blue litmus into red and basic converts red litmus into blue, right?
Yes, sir.
Okay. And what about a neutral substance? If I have another beaker in which I am having water. Okay, this contains water. So if I were to put whether blue or red litmus, yeah. If
Yes,
I
sir.
were to put a blue litmus, let's say this one is blue, and if I were to put a red litmus in water, will there be any change in its color?
No, sir.
No.
No, sir.
We won't be observing any change in the color of the litmus.
Because, sir, water is neutral.
Water is neutral. Okay. One more question to you. That what is actually the natural color of the spatula? Is it
Yes.
red, blue, or purple? Because this lichen, we actually converted it into paper, and we actually made the paper red and blue for our convenience. But in nature, what is the original color of the lichen? Is it red, blue, or purple?
Purple, sir.
It is actually purple. In nature, you will find that this lichen is of purple color.
Yes, sir.
Okay. Okay. So here you see we have got few test solutions. Okay. I will actually blur the inference here so that you can answer the questions. Okay, now you cannot see the answer so that we can discuss. Like if I take a tap water, okay, what will be its effect on litmus paper?
Nothing, sir.
Nothing. Whether we take red or blue one, there will be no change so in the color of the litmus paper. So we say that tap water is neutral.
Yes, sir.
Right? Similarly, if we take a detergent solution, which is basic in nature, as you already know, there's no need
Uh,
to talk about it. But let's say that the red litmus paper should tip. Remember, all the
yes.
components which we have taken here, it is in solution form. None of them are dry, right?
Yes,
They
sir.
are in solution form. Basically, they contain water in them. Okay. So litmus test cannot be done on dry substances. Can only be done on substances which are in the form of solution.
Yes, sir.
Okay. So remember this thing very carefully. Okay. Detergent solution, red litmus solution will be changed to blue. And what about
Yes.
blue?
Nothing, sir.
There will be no change. Why?
Yes.
Because we see that bases have no effect on blue litmus paper. Okay.
Yes, sir.
So here it is actually a base. Yeah. Answer the third one.
Aerated drink. Uh, it won't happen anything to red and changes the blue litmus paper to red. It's
Yeah.
base.
Actually,
It's a acid.
it will be acidic in nature. Very good.
Yes.
What about soup solution?
Is there a soap solution? A base.
It's actually a basic solution. It's basic in nature. Right?
Basic.
What about shampoo?
Acidic.
Shampoo is actually acidic. Okay. Common salt solution. That is very obvious. It has got a
Neutral.
pH of around 7, so it is neutral.
Yes, sir.
Okay. What about sugar solution? That is
Neutral.
also neutral.
Neutral.
Okay. Vinegar.
Acidic.
That is acidic. Okay. What about baking soda solution?
Base.
That is basic in nature. Milk of magnesia. Milk of magnesia is magnesium hydroxide.
Oh.
Is actually magnesium hydroxide. Yep. What is its property? What is its nature?
Magnesium hydrochloride.
Hydroxide.
Hydroxide. Okay.
So is it basic or
Base.
acidic?
Base. Basic.
It is basic. Okay. Washing soda solution.
Basic.
That is also basic. What about lime water? Lime water
Basic, sir.
lime water is actually lime
Lemon
plus
juice.
water. Oh, lemon juice is different thing. You see, people in villages they color their house with the help of lime. That is actually called tuna in Hindi. Okay. So
Oh.
they add lime into water that becomes CaO. So lime water is actually this. This is actually the lime water. This is the chemical formula of lime water. Okay, you must have seen this back in the village that people use lime water to paint their houses. Lime comes usually in white color. When they add water to it, so much of heat is released. Okay, it is left for some time and then is used to paint the walls. So lime water is also what
Basic.
basic in nature. It is also a base. Okay, so that's an interesting. Now, apart from litmus paper, we have got natural indicators as well. To check whether a substance is acidic or basic in nature, we have got natural indicators. Right? We use
Yes.
turmeric as well. You must have noticed that if you were eating some food which contained turmeric in it, turmeric basically means what? It is actually the haldi, right?
Yes.
So if you eat some food which contains turmeric in it and uh, and the full cut on your shirt, So
Yes.
when you put that shirt into the washing machine, or you put some detergent over it, its color must have changed to red.
Yes, sir.
You ever observed that?
Yes.
Yeah. So that actually shows that when we add base to turmeric, its color changes to red.
Yes, sir.
Right. So
Yes.
turmeric is also a national indicator where we can test the basicity of the substance. Okay.
Yes.
So you can actually prepare a card, a greeting card from turmeric paste as well. Like here, this lady has actually taken a turmeric paste and he spread the turmeric paste out in the sun, and basically she converted that turmeric paste into a paper. And
Yes, sir.
here you see he is taking drops of soap solution and making flower patterns on this paper. And so notice the color. So notice the color. It is actually changing to dark red,
Yes.
right?
It's red. Yes, sir. Dark red.
So using the chemical reaction here, she is actually making flower patterns. Okay,
Yes.
that was about how natural indicators can also be used to determine the acidity and basic city of substance. Okay, okay. One interesting question for you. If I talk about the human blood, what is its
Huh?
nature? Is it acidic or basic in nature?
Basic, sir.
It is actually basic in nature. Very good. And it has got a pH of around 7.5. Okay. Okay. So in your previous class, what are the chapters which you studied? I guess these are the chapters, right?
Wait, sir.
These are the chapters in your class 8 actually.
Uh, yes, sir.
Right, Rehan and Ahmed?
Yes, sir. Yes, sir.
Okay, so we are done with the basics. And Ahmed, you actually joined the class late. We were actually doing the test here. Okay, you
Oh,
can still attempt them.
yes, sir. Of course.
Here, just a minute. See the first question.
Mm.
See question number 1.
Yes,
Okay,
sir.
you have got how many questions are there? Question 1, 2, 3, 4, and 5. Okay, you have got 5 minutes to solve all of them. See question number
Oh,
1.
okay. The carbon dioxide gas enters the leaf of the plant through the dash print on the surface. Leaf veins.
No, not leaf veins. If you actually,
Oh,
if you see the
stomach.
process of photosynthesis, okay,
Oh,
plants actually take carbon dioxide from the nature. So the leaves must be having some pores in them, some holes in them. So there are stomata present in them. There
oh,
are
stomach.
stomata present in them. Okay.
Yes, sir.
And stomata have got holes in them. Stomata have got pores in them that are called stomatal pores. So why that is stomatal pores? They take in carbon dioxide and they release oxygen into the atmosphere. Okay, so the
Yes, sir.
correct answer is stomata. See the next question, which of these is not parasite?
Parasite. Uh, a marble.
A marble is not a parasite. What about hookworm? That is also a parasite. Leeches is also a
Yes.
parasite. What about a
Marble.
marble? A marble is what?
A parasite.
It's a parasite. What about pitcher plant?
Pitcher plant is a parasite, sir, but a marble isn't a parasite.
Pitcher plant looks like this that survives by eating dead insects or alive insects
Yes.
as well.
Yes,
Okay.
it's like
So pitcher plants you must have seen, they are carnivorous plants. Okay, and they survive by eating insects Sometimes they consume rats as well. If small rats fall into them, they consume rats as well. Okay, so feature plant, leeches and worm, all of them are parasite, while amarble is not a parasite.
Yes, yes.
Silkworm secrete fiber. You know that
Oh,
we use the fiber secreted by silkworm to create cells. What are those
uh,
fibers made up of?
cellulose.
It is actually cellulose. Okay.
Which
Which of the
of
following is false?
acidic have pH value less than 7 base. Neutral have pH value of 14.
Okay, very good. Neutrals have actual pH value of 7, but the option says 14, so it's wrong. The correct way of making a solution of acid in water.
Water is to add water to acid. So to add water to oxygen. Add water into acid in a shallow container.
Add water to acid. Yes,
Um,
Rehan, is the answer correct or wrong? Yeah, Rehan, can you hear me? Okay, I guess my voice is still not audible, Rehan. If you see, that is
uh,
not the correct method, because if you do so, that will be a very explosive reaction. Normally, what we do, we take up a beaker, okay, we take water, and we add acid to it drop by drop, okay, and we keep tilting the solution, we keep mixing the solution by the help of a filter.
okay, sir.
Let me explain the process here. What happens? Look, it's contains acid. So, to dilute an acid, normally the acids which are produced in lab, they are very concentric, meaning that they are very strong. You cannot even smell the fumes of the acid. That will harm your nasal passage. That will be harmful for your lungs. They
Oh,
need to be diluted. That is, they need to be weakened. Okay, so that they can be used. So what we do, we take a beaker, we keep adding the acid in the form of drops, and we keep mixing this mixture. Okay. If we do just opposite of this, if we instead of taking water in the beaker, if we were to take acid and here we take water, since it is a very concentrated, meaning that is it is a very strong acid, it will lead to explosion.
yes, sir.
The person conducting the experiment might get harmed. Okay, that's why instead of adding water to acid, we add acid to water in the form of drops.
Yes, sir.
Okay, Ahmed. Okay. Okay, that's it for today. I hope the class was interesting.